Companies and governments have regularly invested in solar farms and lost money when weather degradation unexpectedly cut panel lifetime short. As electricity generated from solar energy increasingly matches fossil fuels in price, companies are pressured to keep panels living past their warranty and stretch the billions of dollars paid upfront for their construction. Diagnosing degraded solar panels sooner through a tool functioning like an electrocardiogram would contribute to lower electric bills on clean energy as well as cut manufacturing costs. A solar farm's heartbeat is data on how well it generates electricity. Purdue researchers created an algorithm using the physics of panel degradation that can analyze solar farm data from anywhere, essentially as a portable EKG for solar farms. Real-time diagnostics would ultimately inform better panel designs, the cost-saving treatment that could prolong lifespan and continue to cut electrical bills. If we look at solar modules on the market, their designs hardly differ no matter where they are in the world, just like how iPhones sold in the US and China are almost identical. But solar modules should be designed differently since they degrade differently in different environments. Degradation in humid environments, for example, comes in the form of corrosion, but high altitudes with no humidity cause degradation through the increased concentration of UV light. Like with human diseases, symptoms of corrosion or sun-beaten silicon tend to not show up on a solar panel until many years after the degradation started. Without knowing when degradation is happening, companies tend to compensate for different weather conditions by under or over designing solar panels, driving up manufacturing costs. Purdue researchers used public solar panel data provided by the National Renewable Energy Laboratory to pull together parameters of how well the panels are generating electricity, such as resistance and voltage. When fed into the algorithm, a curve generates to show the power output of a solar cell. In the long term, the researchers hope the algorithm could show how much energy a solar farm produces in 30 years by looking at the relationship between weather forecast data and the projection of electric circuit parameters. Integrating the algorithm with other physics-based models could eventually predict the lifetime of a solar farm.